The chapter is Arithmetic Progressions for Standard 10. The first and the last terms of an AP are 5 and 45 respectively. So A is equal to 5 and AN, or you can say L, last term, is equal to 45. The sum of all its terms is 400. So it's given SN is equal to 400. You have to find the common difference. So let us assume A is the first term and D is the common difference. So Sn is 400 is given. So we will start with Sn is equal to 400. Sn is n by 2 into A plus An. A plus An is equal to 400. So we do not know n. So n by 2. So n is equal to 2 will go here. So we will write n into A is 5 and An is 45 is equal to 2 will go here. So 800. So this is equal to n into 50 is equal to 800. (800 by 50) is equal to 16. So we get n is equal to 16. Now we have to find the common difference. So An is equal to 45 is given. So we will use that. So An is equal to 45. So An is A plus n minus 1 into D is equal to 45. So A is 5. 5 plus n we have already got 16. So 16 minus 1. So 15D is equal to 45. So 15D is equal to 40. Therefore D is equal to 40 by 15. That is equal to 8 by 3. So the common difference is equal to 8 by 3. The sum of first three terms of an AP is 48. So whenever first three terms is given, you have to take let the three terms be A minus D, A and A plus D. We have to take it because if you add this, you will get 3A is equal to. If you take A plus D and A plus 2D, then you will not be able to find the answer. So you should always take it A minus D, A and A plus D. Now sum of the first three terms of an AP is 48. So A minus D plus A plus D is equal to 48. So D and D will get cancelled. 3A is equal to 48. So A is equal to 16. Now if the product of the first and the second term exceeds 4 times the third term by 12, find the AP. So the product of the first and the second term. So first and second term is A minus D into A. Exceeds, that means that is bigger. So A minus D into A minus 4 times the third term. So 4 into A plus D is equal to 12. So this is A squared minus AD minus 4A minus 4D is equal to 16. Yeah, we can substitute A is equal to 16 here and then we can do this. That will be much easier. So A minus 16 minus D into 16 minus 4 into 16 plus D is equal to 12. So I can take 4, I can divide throughout by 4. So this will become 4 into 16 minus D minus of 16 plus D is equal to 3. So this is 64 minus 4d minus 16 minus d equal to 3. So you get 64 48 minus 5d is equal to 3. So 5d is equal to 45. So d is equal to D is equal to 9. So we got A and D, and you have to find the AP now. So the AP is equal to the first three terms are A minus D, A plus D. So the second term is 16. So A minus D, so this is 7. Then 25. $34, etc. Find the 60th term of the AP, 8, 10, 12, etc. if it has a total of 60 terms, and hence find the sum of its last 10 terms. So we have to find the 60th term, and the number of terms n is equal to 60 is given. So A is equal to 8 and D is equal to 10 minus 8. So equal to 12. 2. So we have to find A60, the 60th term. So this is equal to A plus 59D, that is equal to 60 plus 59 into 2. So this is equal to A is 8, 8 plus 59 into 2, that is equal to 8 plus 118, that is equal to 126. So A60 is equal to 126. Now we have to find the sum of its last 10 terms. So to find the sum of the last 10 terms, so we have 60 terms. So we will find sum of last 10 terms is equal to S60 minus S50. The sum of all the 60 terms minus sum of the first 50 terms, you will get the sum of the last 10 terms. So S60, now we will find S60 is equal to n by 2 is 60 by 2. The first term is 8 and the 60th term is 126. So you get 30 into 134. So you get S60 is equal to 4020. 4020. Now S50 is equal to 50 by 2. 2a plus n minus 1 into d we will find, because we have not found the 50th term. So we will use the formula n by 2 into 2a plus n minus 1 into d. So 2a is 2 into 8 plus 49 into 2 n minus 1. So 49 into d. d is 2. So this is equal to 25 plus 98, that is equal to 25 into 114. So you get this answer as 2850. So therefore sum of last 10 terms is equal to S60 minus S50. So that is 4020 minus 2850. So 1170 is the sum of the last 10 terms. The sum of the first p terms of an AP is same as the sum of its first q terms, where p not equal to 2, then you have to prove the sum of the first p plus q terms is 0. So sum of p terms, so SP is equal to SQ. So we'll write this as sum of p terms is equal to p by 2 into 2a plus p minus 1 into d. So a is the first term and d is the common difference. So this is equal to q by 2 into, it is the same AP. So q2a plus q minus 1 into d. So 2 and 2 will get cancelled. So you get 2AP minus, plus 2AP plus PD into P. So it is P squared D minus D into P. So minus PD is equal to, here also this 2 and 2 has got cancelled. So now 2A, multiplying Q throughout, 2AQ plus QD into Q. So Q squared D minus DQ. Now 2AP, we can bring it this side, 2AP minus 2AQ, then P squared D minus plus P squared D minus Q squared D, then minus PD plus DQ is equal to 0. So 2A into P minus Q, with this we can write D into P squared minus Q squared minus D into P minus Q is equal to 0. So we have this P squared minus Q squared can be written as P plus Q into P minus Q, and we can divide throughout by P minus Q. So you get 2A plus D into, you are left with here P plus Q minus D is equal to 0. So this can be written as 2A plus D can be taken out. Here there is D here and here also D. So D into P plus Q minus 1 is equal to 0. So we will leave it here. Let this be equation 1. Now we have to find the sum of the first P plus Q terms. So S of P plus Q is equal to, so n by 2. So P plus Q by 2 into 2A plus n minus 1 into D. See, n minus 1 will be P plus Q minus 1 into D. This is equal to, now 2A plus P plus Q minus 1 into D. We have already got this is equal to 0. So this full term is equal to 0. So P plus Q by 2 into 0. So this is equal to 0. So S of P plus Q is equal to 0.